Okay, in this video we're talking about how to solve two-step equations. And I have an example for one right here. And before we go into how to solve that, I think it would be helpful to see one way that these equations are actually made. Let's say I want to make a new equation to solve, and I'm going to say that x equals 4, just to start out with. Now what I can do is I can add things to this equation to attach things to the x, and then that consequently is going to do things or change the other side. So right now x equals 4. Now let's say I was to multiply both sides by let's multiply both sides times 6, let's say. Okay, so I'm going to multiply the left by 6 and the right by 6, and now I'm going to get 6x equals 24. That should look familiar to you guys because this is a one-step equation. If we were given the equation 6x equals 24, we could divide both sides by 6 and we would get x equals 4. But I'm going to take it one step further, and I'm going to actually add, let's add 10 to this. So I'm going to add 10 to both sides. Now I'm going to get, typically we write the x first, 6x plus 10 equals 34. And this would be a very typical type of problem that we would see. It would say solve for x, or solve the equation 6x plus 10 equals 34. And in order to solve this equation, I'd work backwards. I would subtract 10 from both sides, and I would get my 24. Oops, can't see that too well. And I would have 6 equals 24. And then I divide both sides by 6, and I would get the original x equals 4. So that's one way that I could create an equation like this. Let's do one more. Let's say I want my x to equal negative 9. Okay. Now I'm going to make this a little more tricky. X equals negative 9. Let's multiply both sides by negative 3. Okay, not subtracting by 3, I'm multiplying by negative 3, so this would be a positive 27. Negative 3x equals positive 27. And if I wanted to subtract 11 from both sides, I would get negative 3x minus 11 equals, I think that's 16. And then maybe I would see this type of a problem, and then they would say solve for x, and I'd have to do those steps in reverse order in order to find out that x in fact equaled negative 9. Okay, so let's say right away we don't know what the solution is. Well, what we're going to do is we're going to start to take things away from the x in reverse order that we think they got attached to x by. So for example, right now we see that 2 is being multiplied by x, and then this total is being 3 is being subtracted from this total, and all this equals the 12. So what I'm going to do, since I see that the x is being multiplied by 2 and then 3 is being subtracted from that, I'm going to undo the negative 3 by adding 3 to both sides. So if I add 3 to both sides, I get 15 over on this side, and the negative 3 and the positive 3 cancel out, and I'm just left with 2x. So I know that 2x equals 15. Now this is maybe an unusual one, but I could now divide both sides by 2, and I would get x equals, and we could maybe write it either way. We could either leave it as 15 halves, or we could write 7 1/2. Okay, and that would actually be our final answer. If you wanted to check this, all you need to do is simply plug in x equals 7.5, and for x. So we have 2 times 7.5 is 15, and 15 minus 3 is 12. And so we get the correct answer. Now, let's try another one. And I'll draw a line here. Okay, and so I'm going to see that right now the negative 3 is being multiplied times the x, and then all of this is being added to 8. And so I'm going to work in reverse. Or you can see that if I was to divide by negative 3 first, I'd have to divide this whole thing by negative 3, and then I would get x over here, but then I'd get 8 over negative 3, and that would be a more difficult fraction to work with. So what I'm going to do instead is to first take away the 8, okay, and then I have a 6 equals negative 3x, and then in order to undo the negative 3 from the x, I'm going to divide both sides by negative 3, and I get x equals, and then we know that positive 6 divided by negative 3 equals negative 2. It's very easy to check this. We simply plug in negative 2 in for x, so negative 3 times negative 2 gives us a positive 6, and 6 plus 8 is 14, and that is correct. Okay, let's do a few more. Again, this is kind of a skill that takes some practice, so I'm just going through a few examples for you, but you can it does really take a lot of practice to really getting comfortable with this. Okay, so in this case, I see that x is being divided by 5, and then this total is 3 is being subtracted from this total. So in order to undo this 3, what I'm going to do is add 3 to both sides. There we go, add 3, and we get negative 25 equals x over 5. And then in order to undo this x divided by 5, what I'm going to do is multiply by both sides by 5, or 5 over 1, and I get x equals, and then negative 25 times 5 is negative 125. And again, you could check this. Simply put in negative 125 in for x, and negative 125 divided by 5 is negative 25, and negative 25 minus 3 is negative 28. We'll do one more. Now this is a little bit different. Okay, this is saying that the sum of x plus 7 is all being divided by 6 here. So we need to work away from the x first, so we're going to get rid of this divided by 6 by multiplying by 6. So I'm going to multiply this side by 6 over 1, and then I'm going to change this 1.5 to 3 halves, and then multiply that times the 6 over 1. I think that will make my math a little easier. So these 6's cancel, and I'm left with x plus 7, and then that equals, I can cancel this a 1 and 3, so that's 9 over 1, or 9. And now I can undo this plus 7 by subtracting 7, and I get the answer of x equals positive 2. If I want to check this answer, let's put in 2 for x. So 2 plus 7 is 9, and 9 divided by 6 is, 9/6 reduced is 3 halves, and we know that 3 halves is the same as 1.5. So again, that is a few problems that I showed how to do, and as I started, one trick that you can try is to think about how did they get this problem in the first place and then undo that. Or another strategy is to work starting from the things that are furthest away from the x and work closer and closer towards the x. But really and truly, to get really good at this, it's just practice. And you'll see how these also apply to real life scenarios when we do the word problems. As always, thank you for watching.